Okay, guys. In the very first place, my name is Alexey Kureev, and I'm a React Native developer in a company called Wroclaw, originally in Netherlands, Amsterdam. And today I'm here to talk a little bit about React Native and about network layer in React Native in particular. So nowadays, it's really hard to imagine a mobile application that doesn't have any kind of network request or something like a network layer at all. Before this conference, I checked my phone and tried to find any kind of applications that doesn't use any networking at all. So I managed to find only one application that doesn't use anything, like no network at all. Can you guess what it was? It was my calculator. So that's the only one on my mobile phone that doesn't use anything. So let me make an assumption. So unless you want to build something like calculators with React Native, you probably will end up having some certain knowledge, maybe some fundamental knowledge about the way how networking works in React Native. You might think that writing networking code is like super straightforward. You know, we used to do it in the web. But apparently writing good networking code is not that easy. Because depending on your software needs, on your platform, you will have to overcome so many different issues like dropping internet connections, connection failures, or maybe even like working offline. I pretty much understand that I won't be able to cover all these topics like in these 30 minutes, although I already checked it out and there is one talk about offline applications a bit later on this day, so this is really awesome. But instead of going through all these topics, I will try to give you some overview of the way how networking works in React Native. So this talk is going to consist of a couple of parts, and this is like a mind map of the first part. We're going to start from React Native as like a building block or like a platform. We're going to consider some APIs that React Native exposed to JavaScript in order to facilitate this networking. And later on, we will take a glance how React Native abstracts things on top of iOS and Android in order to perform and fulfill this request. So these are three APIs that React Native exposed to JavaScript. So I'm saying that because you probably might or might not know, but these APIs are not a part of the JavaScript language. So it's out of scope for JavaScript engine to implement them. And therefore, it's up to the underlying platform to implement these APIs and bridge them to JavaScript runtime. So basically, JavaScript runtime looks like this. There is a thing like JavaScript API, which is basically a standard ECMAScript standard. We all know this. And there is an underlying platform API. So all the things like set timeout, set interval, all networking stuff, and some other maybe, I don't know, APIs I didn't mention, altogether, it's a JavaScript runtime that we have in our browsers or in our React Native application. So now, I'd like to quickly recap all these three APIs one by one. So the very first one is XML HTTP request. And it's quite a, I don't know, old-fashioned way of doing networking, but it's absolutely fine. It was brought to us by Microsoft like a long, long time ago, and later on it was adopted by all the major browser vendors. So every single API brought to us by a platform consists of, well, you can separate it by two parts, like a front-end part and a back-end part. And the front-end part is something that we can access from JavaScript. Basically, this XML HTTP request is going to be front-end part. And the back-end part is something that underlying host platform provides to us. Like, basically, in browsers, it would be just some C++ code, probably, that works on top of the underlying platform, like Windows, Mac, whatever, you name it, and facilitates this request. In React Native, it is a networking model. So every single time when we make this request, our request goes to React Native, and React Native routes this request to networking model that is responsible of abstracting underlying things. So basically, networking model knows on top of which platform it runs. We have networking model for Android that works on top of OKHTTP library, and we have a networking model for iOS that works on top of an SURL session thing. So this is about XML-HTTP request. The second in the queue is fetch. So fetch is kind of new kid on the block. It was designed to be more elegant and extensible and just a, more reusable and basically more fancy way of doing network requests than XML-HTTP request. The thing is that in our web environment, like browsers, for instance, we use underlying implementation of the fetch that is backed by like a separated native model on the browser side, right? But in React Native, we don't. In React Native, fetch is polyfilled. That basically means that all the functionality we have in the fetch works on top of XML-HTTP request, which is absolutely fine, although you need to take into account that if something is not possible in XML-HTTP request, I mean in the current implementation brought to us by Facebook for some reason, it's not possible in the fetch either. And therefore, if it relies on XML-HTTP request, it also relies on the networking model of React Native. And the very third one, called WebSocket API. And this is actually a completely different beast, because instead of just like, I don't know, fire and forget network request, WebSocket is a full duplex communication protocol that establishes a persistent connection between server and the client. So either party can send data over it. And even if you never used WebSocket, you actually did if you try to run any kind of React Native application, because every single time when you run a mobile application, like React Native application, it also starts a packager. And every single time when you run it in debug mode, or in development mode, sorry, you establish this WebSocket connection between packager and your application. So every single time when you change something locally, the patch goes to your mobile application using WebSocket. And therefore, it's like up to mobile application to process this patch. Like if we want to, let's say, hot reload our code or replace models, whatever. And this is about these three APIs. And now I think we can take another look on this picture and try to imagine the entire flow from A to Z. So it starts from JavaScript. We go to React Native Platform. React Native Platform routes it to networking model. Networking model use one of the underlying implementations, as I already mentioned. For instance, here on the slide, I have networking request go through iOS, which basically means that it's going to use an SURL session in order to fulfill requests and make this, make this request to request this resource. And this is actually the very first part of the talk where I wanted to outline some basic concepts behind networking. In the second part, I will try to address some things like real-world networking issues, because even though React Native is awesome, of course, there are still some issues to it. And today, we will try to address some of the networking issues in React Native. Okay, so I'm about to start from debugging network requests. But before I even continue, I want to ask you a question. Let's say we can debug our JavaScript in Chrome. It's not a secret, right? So we fetch it to service worker. We can place breakpoints, console log things. But how many of you think that we can also debug network requests in Chrome DevTools? Please raise your hands. OK, some of us. Awesome. So probably I'm going to disappoint you. Because I'd like it to work this way, although it doesn't, apparently. And there is a reason to it. So basically, what happens here is that, as I said, we have all this networking API brought to us by React Native. So we have front-end and back-end part to each of them, right? And the front-end part is always sending all the requests through React Native platform. And React Native platform is something that runs on our either emulator or mobile physical device, whatever. But anyway, it doesn't use anything of the Chrome platform. So it's, basically blind to Chrome, because Chrome doesn't see this request because it doesn't, this networking request doesn't use Chrome API in order to fulfill them. So it always goes through mobile platform, and that's why it's not even visible in the networking tab. But there are some ways to overcome these issues. The very first one, and kind of blunt way of doing this, you can use TCP traffic monitoring. So you can install Charles Proxy, Wireshark, whatever you name it, and then list all your TCP connections. And then just go one by one checking every single request. Although this approach also not going to work if you debug your network on physical device. Because if you debug it on the physical device, then, and let's say let's say you make this request, right, like to remote resource, then it's still going to go through the physical device then, because that's where your JavaScript and your React Native application runs. It's not like your laptop or something. So it always will go through the physical device, and therefore it won't be visible for the TCP traffic monitoring tool that you're going to use on your desktop or laptop. But there is a better way of doing this. You can use XHR interceptor. And this is actually a private class of React Native, and it's not documented anywhere, but basically it is capable of overriding standard XML HTTP request in order to attach some places where you can bind callbacks. So, for instance, if we talk about XHR, right? We have the moment when we create XHR, we can attach callback to it. We have a moment when we attach headers to XHR, and we also can have a hook for that. And of course, when we send it, there is also a hook for that. Although it's like a low-level API, and probably you don't want to use that kind of thing in your application. So hopefully, there is a really great tool created by Infinite Red called Reactatron, which is like a Swiss knife for your React Native applications. It works on top of this XHR interceptor and WebSocket interceptor for WebSockets, apparently. So I strongly recommend you to use this tool because it's really like painless experience. You just install it, you run it, you see all your requests, you can debug it straight away. This is just amazing. The second issue I'd like to focus on is going to be about sending binary data over the wire. If you ever developed an application that works, for instance, with images, you probably experience quite some issues about that. Because React Native implementation of XHR is not capable of transmitting binary data. Basically, neither front-end or back-end is capable of doing this. On the front end, we don't have blob constructor or file constructor. On the back end, we don't have any kind of code that is responsible of handling blob data. So back in the days, we used to work with some workarounds for that. And one of the workarounds, if you make a request like to the remote region, and we want to fetch blob, don't ask me why, but let's say we need to do that, right? This is the best example I could came up with. So we make this request, and if you want to get back an image, let's say, we actually need to make a really nasty hack. We need to convert it to base64, push it back through React Native because it will be then a string, right? And React Native is capable of processing strings as a response, so it will go to JavaScript as a string. And can you, just for a second, can you imagine like base64 or something like 10 megabytes of image sending over the bridge? So it's going to be a huge performance bottleneck. But it's not limited by it. It goes to JavaScript, and then we're like, oh, OK, so we fetch this data. Now we probably want to just render this data to image, right, and see it on the screen. So what happens next? You're saying, like, OK, this is my base64. You supply it as a source for image tag, and then it goes back to native platform. So we have this double overhead of sending base64 over the bridge, like back and forth, which is kind of really crazy. But apparently, there are two workarounds against this. So in the first place, you can use React Native Fish blobs, which is ready-to-use third-party library that implements blob primitives and actually works in a really neat way, in a way how it's supposed to work. At the moment when we fetch blob from the server, it stays on the React Native side, I mean on the native side of our application. We construct a JavaScript object, a blob object that keeps a reference to this file. And we send only this object over the bridge. So it's just a tiny one. It has a tiny footprint, so there is no really big overhead there. So we send it to JavaScript, and JavaScript is saying like, yeah, OK, this is a blob file. I supply it to image. And then this reference goes back to native platform. And at the moment when we render something, it actually resolves this underlying reference and uses physical binary data, which is really a great approach. But what I have to say to it is that quite some time ago, I think Expo contracted Callstack, these beautiful engineers there, to implement the support of binary data transferring over WebSockets. So, and now, like in the latest version of React Native, I believe, it's already shipped. So you can use blob constructor, file constructor, and transmit your binary data over WebSocket connection in the latest version of React Native. And this is just dope, really. And there is a follow-up request, pull request, that's going to implement exactly the same for XML HTTP request, which is going to be just amazing. But it's still like under review stage, and we're probably going to struggle a little bit with it, but we will get through it, I promise you. And there is one more thing I'd like to talk to you about. It's related to credentials policy. You already know that there is like a web environment and there is a mobile environment, right? We have two different paradigms, whatever you call it. And in the web, there is a specification that tells like, yeah, OK, there is XHR request, for instance, and by default, it doesn't send any kind of credentials along with the request. If you want to send additional credentials, you have to use flag with credentials equals true, which is false by default, apparently. And then, yeah, here we go. We send these credentials along the request. Although, on mobile platforms, and this is one of these rare cases when Google and Apple agreed on something, they always send all your credentials by default. So there is no need of flags or something. But let's say we have React Native. And React Native is somewhere like in the middle of it, right? So it's kind of tricky to say which approach React Native should take. Either web one, because we're kind of trying to be compliant with the web protocols, or mobile one. So we have kind of this situation, like we want to send cookies, and one platform saying like, yeah, OK, let's send the cookies. And the second one is like, oh, no way, we're not going to do that. And funny enough, but in the very beginning of React Native, XML HTTP request was sending the cookies all the time, even though it was kind of compliant with specification of XHR. So theoretically, it shouldn't be doing this. And therefore, in the later versions, there was like an issue report, like, OK, we shouldn't do that. So it was changed. And then lots of applications that were relying on this approach, like that we sent all the cookies by default, basically started to crash. Because like, what the hell? Now we don't have cookies. We can't authorize our requests with, I don't know, certificates or our credentials or whatever. And then they reverted it back. So it's really tricky still, and I just want to raise your awareness about this. So yeah, just take a look on the implementation in the next versions. Keep an eye on the changelog because that can change still, and it's an open debate and still not yet resolved. And you know what? I think this is kind of about it, but before I finish my presentation, I really want you to have a round of applause to this guy because this guy drew all these illustrations, and I think he really deserves it. Thanks. So if you want to contact him, have nice slides or something, here is his email. I'm going to share slides afterwards. I'm not sure if it's going to be handy for you, but still. And yeah, I think that's it. And time for the break for some meal and having some party. Thank you.